Welcome to the Explainer. Today, we're undertaking a high-stakes, step-by-step tactical briefing. Our mission? Executing a literally flawless iOS XE upgrade on a Cisco Catalyst 9200 series switch. Now, upgrading your network infrastructure doesn't have to be intimidating, right? But it absolutely requires a structured operational framework. So I'm going to walk you through exactly how to get this done smoothly, securely, and efficiently, using the exact workflow that real-world network engineers rely on every single day. Okay, let's dive into this. Skipping a step in this process is exactly what turns your quiet, productive afternoon into a very long, very stressful night. Upgrading a Catalyst 9200 isn't inherently the most difficult task out there, but man, it is incredibly unforgiving if you get kind of sloppy. Missing a single detail is what leads to network downtime and just frantic troubleshooting, and that is exactly what we are going to avoid today. So here's our mission flight plan. We'll conquer this chronologically. First, preparation and pre-checks. Second, transferring the new image. Third, verification and installation. Fourth, validation and cleanup. And finally, number 5, real-world survival tips.
All right, Phase 1, preparation and pre-checks.
Consider this our reconnaissance phase. Before pushing any changes whatsoever, there are 4 absolutely vital baseline checks you've got to perform. First up, check your current software version. Second, check your flash space, because you literally can't copy a new image without the room for it. Third, verify the overall health of your stack if you've got one running. And fourth, confirm your boot mode. Now, for the 9200 specifically, install mode is explicitly the recommended way to go. Moving right along to Phase 2, transferring the new image. Okay, so you've grabbed the correct iOS XE.bin file from the Cisco Software Download Center. Now, how do we actually get it onto the switch? Well, you generally have 2 main methods. TFTP is your classic tried-and-true approach, but if you have SCP or Secure Copy Protocol enabled on your network, that is for sure your preferred route. It's secure, it's reliable, and it's exactly what you should aim for. And this brilliantly illustrates why diligence is absolutely key as we hit Phase 3, verification and installation. The file is sitting on the switch, but hey, we aren't done just yet. This is the critical execution phase, and your margin for error here is exactly 1. Cisco provides an MD5 or SHA checksum for your downloaded file, and you absolutely must verify that against the switch. If just one single character in that cryptographic hash doesn't match, you've got a corrupt image, and installing that equals a very, very bad day. So, if it doesn't match perfectly, stop right there. Now, assuming your checksum is perfect, it's time to actually execute the installation using install mode. The exact command syntax you're going to use is install, add file, activate, commit. Let's break down the logic of why this works so flawlessly. Add stages the image on the switch. Activate tells the switch to actually swap over to that newly staged image. And commit is what makes that new image persistent after a reboot. It's just a super elegant, safe, and logical way to handle the whole software swap. Okay, on to Phase 4, validation and cleanup. So you've committed the image, which obviously requires a system reload. Keep in mind, some installs auto-reload, while others are going to wait for a manual push from you. But listen, just because the lights are blinking again doesn't mean the mission is fully accomplished. You need to validate 3 crucial post-reboot checks. 1, verify the correct new version is actually running. 2, check that all stack members are communicating perfectly. And 3, ensure your interfaces actually came back up. Once you've validated the switch is completely healthy and running the new code, there's one more quick thing. Step 8 is cleaning up your old images. Technically, yeah, this is optional, but practically speaking, it's just smart engineering. Running the cleanup command frees up incredibly valuable flash space, and perhaps more importantly, it totally avoids future confusion for whoever has to log into that switch 6 months down the line. Just keep your flash storage tidy, folks. Finally, Phase 5, real-world survival tips. We've completed the technical workflow, so let's look at some field intel and totally avoidable mistakes. First up, please do not upgrade during peak hours unless you actively enjoy getting angry phone calls from your users. Just schedule a proper maintenance window. Second, always back up your config. Third, upgrade the whole stack at once. Please don't mix versions across the stack because it will absolutely break things. And finally, read the release notes. Sometimes new versions come with fun little surprises like depreciated commands or changed default behaviors. You really gotta know before you go. So the crucial point is, to bring it all together, here's your ultimate 5-step cheat sheet. 1. Copy the image securely. 2. Verify the checksum perfectly. 3. Install using the add, activate, and commit syntax. 4. Reload the switch. And 5. Validate your interfaces and stack health. It's a clean, reliable, and totally professional workflow. Which brings us to the end of our briefing, and honestly, leaves us with one vital question. Are you fully prepared for your next upgrade, using a structured operational framework? Or are you just hitting enter and crossing your fingers? Challenge yourself to apply this foolproof process, ditch the guesswork, and make your next Catalyst 9200 deployment a total success. Thanks so much for joining me on this explainer, and I'll catch you on the next one.